Lesson 6, activity. So we're going to first calculate a formula for the derivative and then find the equation of a tangent line for each of these. Good notation all the way around. If you take a derivative, write down f prime of x equals first. Okay, so x cubed becomes 3x squared. Subtract 4x squared becomes 8x. That 2 just comes down and multiplies by the 4. Plus 5, that's a special case. The derivative of 5x is just 5. Minus 3, that's a nothing. I won't even write it. Okay, now we need the tangent line. So we got to find f of 2. So that means plugging 2 into the original. And it says no calculators, so I'll try this one on my own with no calculators. 4 times 4 is 16, plus another 10 minus 3. Negative 8 plus 7, I get negative 1. I'm hoping that's right. Then we need to find the slope of the tangent line, which means plugging 2 into the derivative. And so you'll notice the good notation here, f of 2 and then f prime of 2 lets the reader know exactly what's happening. So we're plugging 2 into the derivative. And so we get 3 times 4, that's 12, minus 16 plus 5. I think that's equal to 1. And now we're going to do our standard mx plus b stuff. The calculus on this one is done. Y equals, so the slope we just calculated is 1x plus b. We're going to plug in the coordinates of our point. Probably should have written the point over here. When x was 2, y was negative 1. So those are the things that we plug in for x and y. Negative 1 is the y, 1 times 2 for the x, plus b. Subtract 2 from both sides, and we get b is negative 3, which means our final equation is y equals 1x minus 3. Probably don't need to write that 1. So that's the equation of our tangent line, y equals x minus 3. Number 2. Okay, before we can take a derivative, we need that f of x function to look like x to a power. So the 2 is there copied. This is really x to the 4/3. That's not a calculus thing. But now that it looks like 2x to a power, we can take a derivative. So let's do that here. F prime of x equals, the 2 stays in the front, the 4/3 comes down, copy the x, carefully subtract 1 from the power, and then we'll go ahead and smush the 2 in with the 4/3. So 8/3 x to the 1/3. And that's f prime of x. So now we're going to do our point calculating. So this is the tangent line at 8. So I guess we want to find the point at 8. What's the y value at 8? Okay, so you could either plug 8 in for the x in the original or in the newer one. I like plugging into the original. I think radical form is friendlier for people than exponent form. Okay, so I'm plugging 8 in for x. 2 times the cube root of 8 to the 4. Okay, so this again says no calculators, and it seems like that's a really mean thing to do to you. 8 to the 4th is not the easiest number in the world to calculate by hand. However, there's some nice algebra thing from before that you should know. That you could do that 4th power inside, or equivalently, you could do it outside. And without a calculator, it is much better to do it outside. So it's the cube root of 8 with a 4th power outside. Cube root of 8 is 2, and now we can do the 4th power. So that's 2 times 16, which is 32. Super. So that means the point we want to hit is 8, 32. Now we'll do the derivative at 8. This will calculate our slope for us. So the derivative is way over here. So this thing, 8/3 times x to the 1/3. Well, I got to tell you, I actually, again, prefer that to be in radical form since I have to plug in. So let's do 8/3, and then we know that the 1/3 power means cube root. So that seems like a more user-friendly version of the derivative. So 8/3 times the cube root of whatever x is. In this case, it's 8. So this is 8/3 of cube root of 8 is 2. So that's 16/3. Okay, and now we will start our mx plus b stuff. We know that the m we just found is 16/3. So I've got y equals 16/3 x plus b. I'm going to plug in my 8, 32. So 32 equals 16/3 times 8 plus b. 32 equals, all right, so I think that's 128/3 plus the b. This one is really 96/3, that's the 32. And then I'll subtract the 128/3 to get my b. Sure wish I had my calculator with me. So that's a 28 and another 4. That's 32, but it's negative 32/3. And so then finally our equation for the tangent line is y equals 16/3 x minus 32/3. Okay, number 3, f of x equals x squared plus 1/x. Like I said in the demo, soon enough we will have a derivative rule for taking the derivative of quotients, which this thing is, but at the moment we don't officially have any quotient rule, so we have to do some rewriting before we can apply the rules that we do know. So this is still f of x, and we're going to take advantage of the fact that we can split this into 2 fractions, both of which have that denominator of x. This is us using the hint. If that's not clear to you, I'll say, well, if I just handed this to you and I said make 1 fraction, what would you get? Hopefully you see you'd get exactly back what you started with. So it's okay to split this up because it has just a single term in the denominator, and we split it up over the multiple terms in the numerator. And let's clean this up just a little bit more. This is really x plus 1/x. Now you're welcome to rewrite this thing as x to a power, right? That's oftentimes what we need to do. I'm actually going to use it in the 1/x form, but either way is okay. All right, and now we are interested in our derivative. So the derivative of x, that's just the number that's in front of it, which is an invisible 1, plus, and then we have a special case for a constant over x. Constant over x becomes negative the constant over x squared. So this just becomes negative 1/x squared. And so that's my derivative, 1 minus 1/x squared. It would be totally fine for you to use the power rule on this thing. It would take a little bit of rewriting to get it into this friendliest form, but you'll get there. Okay, next up we are plugging the particular x value into both the original function and the derivative. So this is x equals 1 that we're interested in. So I want to find f of 1 first. I'm going to use this version right here. So it's 1 plus 1/1, 2. So when x is 1, y is 2. And now we'll do our derivative here, evaluated at the same x equals 1. And so the derivative version I'm looking at is this one right here. So it's 1 minus 1/x squared, 1 minus 1/1 squared. And 1 minus 1 is 0. Hey, how about that? So y equals mx plus b, 0x plus b. Okay, the 0 doesn't really bother me. I'm just going to plug in my 1 and my 2 as usual. So 2 equals nothing times 1 plus b. So apparently b is 2. And so then the final equation for my tangent line is y equals 0x plus 2, or better, just y equals 2. Okay, last one, number 4. So here we've got x to the third minus 3, the whole thing squared. Now, soon enough, we will have a rule that will allow us to take a derivative of this function in its current form. It's called the chain rule, but we don't have that yet. So again, we have to do some rewriting in order to put this function into a form that we can handle at this stage in our course. And so the hint there is to distribute or FOIL. So f of x equals, so x cubed minus 3 squared really means just multiply it by itself. And now we'll FOIL, right? So first is x to the 6th, outers minus 3x to the 3rd, inners minus another 3x to the 3rd, lasts plus 9. So putting together those two like terms in the middle, x to the 6th minus 6x to the 6th, 6x to the 3rd, plus 9. Okay, so now it's in a form that's differentiable for us. So let's do that here. F prime of x equals, okay, x to the 6th becomes 6x to the 5th, minus that 3 comes down, multiplies by the 6, gives 18, x to the, subtract 1 to get it 2. plus 9, that becomes a plus nothing, which I won't write. Okay, now we're going to find the coordinates of the point when x is 2. So we're plugging into the original now. You could plug into this guy. I don't know if that's any easier or harder. I'm going to plug into the original, this one. So that becomes 2 to the third minus 3, the whole thing squared. So that's 8 minus 3 squared, or 25. So the coordinates of the point we're interested in are 2 and 25. Okay, and then we're going to take that same x equals 2 and plug it into the derivative. So f prime of 2 equals, okay, so my derivative is, the one I'm looking at is this purple thing right here. 6 times 2 to the 5th minus 18 times 2 squared. Okay, no calculators, so let's just grit our teeth and deal with it. 2 to the 5th, is that 32? Minus 18 times 4. Okay, 6 times 32, that's 192. Minus 18 times 4 is 72, so I get a 120 at the end of the day. So that is the slope of our tangent line. So we'll start with our mx plus b business, 120x plus b. And then we're going to plug in the coordinates of our point for x and y. So the y is 25 equals 120 times the x is 2 plus b. 25 equals 240 plus b. Subtract the 240 from both sides. We get negative, is that 215? And so our final answer, the equation to the tangent line here, y equals 120x plus negative 215. So I'll just write minus 215.